Hello, welcome to another Stat 432 video. This video is a continuation of the previous video about the UCI heart disease data set, the analysis that we're doing with that data. So in the last video, we mostly sort of talked about the goal of the analysis and we started to look at the data. We're going to do a lot of the same in this video. But I want to start actually sort of working with the data a lot more in this video. But roughly, what I plan to do in this video is recap the data because I need to refresh my own memory. And like I said last time, but I didn't do, I'm going to start taking some notes on that, and I'll sort of show that process. Then we really need to test, train, split the data. Then we're going to look at the data some more. Especially start looking at the response variable a little more seriously. And then maybe we'll fit our first models of the data. But I'm going to, again, try to keep this video capped at about an hour, maybe less on this one even. So we'll see how far we get there. But an end goal is sort of having a better understanding of the response variable and sort of how to start thinking about predicting it. Okay, so here I am inside of our studio. I sort of just opened up the zip file that was provided, which is that GitHub repo. And don't forget that there's this README here, and that sort of describes everything that was initially provided in this repo. But so I'm going to create another new file. We'll just make it a random markdown file, which I'm going to call notes. Let's call this notes.md. So I'm just going to take notes along the way here. Another file that I'm going to create is an R script, and I'm going to call this scratch.r. So these are going to be two files that sort of just help me collect my thoughts with respect to this analysis. Both sort of, well, we'll just see how I do it. But I could just start putting stuff into this R markdown file, but I don't want to do that yet. I don't want to be constrained by like having to put things in certain sections and thinking about the final product. I just want to work with the data. So I'm going to take some notes so I make sure I know what I'm doing, and I'm going to start writing all my code down. But I don't want to like. I guess what I want to sort of say is much like when you do a math problem, you kind of have a sloppy copy, or at least I would hope you do. And then you copy the relevant bits that you actually need to solve the problem onto your final homework solution that looks nice that you turn in so you don't annoy the grader in whatever class you're dealing with. Well, I kind of want to mirror that idea onto a data analysis, right? So I, as the person who would potentially read your analysis, I'll be blunt. I kind of don't care what you did along the way. I mean, I do because I'm an educator and I'm interested in the process. But ultimately, someone who, say, wanted to use or not use your data product, this model that you created, they don't care how you got to the answer. They just care if you have an answer and that it's a valid answer. So while we care, like we, the people doing the analysis, care about some internal bits and pieces of the analysis, sort of like stakeholders in the area that you're working, they might not care about all that. So we don't want to dump all of that into the report. In the report, we just want the most relevant bits that actually matter. But to us, we want to track some more internal stuff. Okay, so right. So I want to take some notes. So I'm going to call this document notes. And first, I want to start taking some notes on the data. And so in the data, there are these variables, right? So I'm actually going to copy paste some of this. Okay, and I don't particularly care for these numbers or even these numbers, so let's get rid of as much of that as possible, as quickly as possible. Let's see here, a little bit like that. There's probably faster ways to do this, but, Oh, no, okay. Okay, cool. All right, and then just because I want to do something like this. Okay, so that way if I rendered it in Markdown, it would look like code. Okay, so age. So I want to. Oops. Okay. So I want to sort of put the meanings of these things in here. This will later sort of, we can use this as our data dictionary in our report. So this is like this. Okay, where's CP is number 9. Okay, so this is chest pain type. There's some more information there, but we'll come back to that. Thrust BPS, that is here. That's number 10, resting blood pressure. Okay. There's probably a faster way to do this, but this is how I'm doing it. Okay. Cole, I believe, is cholesterol. Let's see, that's number 12. Cool. Okay. FBS is fasting blood sugar. Oh, this is just a binary, but okay. Huh. That's funny. Cholesterol was spelled wrong. Okay, that's great. Resting EKG is that. Okay, Thalatch. Let's see, that's number 32. So that's this. Okay, so this is getting into. Aha, yeah. So this piece of information here is not in the process data that we're using, but yeah. So like I said, well, this is the type of stress test that they were put under. Okay, interesting. So this is a bike. This is a rowing machine. I don't know what this is. I don't know what these are, but these are known protocols for like stressing a heart via exercise. Xang, I think, is related to that. Let's see. That's number 38. Exercise-induced angina. Okay. Old peak is not sure what that means, but we'll figure it out. Slope. Does it say what ST time when ST measured depression? We need to figure out what ST means at some point. But anyway, CA is the thing about staining, I believe. Where is CA? What number is it? 44. Aha. Okay, cool. Thal is this here. And then this is presence of heart disease. Okay, so I wanted to do this to think about these things. So let's see, that would go there. That would kind of be like that. Like that, like that, like that, I think. Okay, so I wanted to think about, let's do this too. And then let's maybe zoom in just a bit. Don't love it, but we'll deal with it. Okay, so thinking about these variables a little again. So a row in this data is an individual. It's a person who was at one of these hospitals. And then these are the columns, so the attributes that we have about those individuals. So this is the one we're trying to predict. And remember that we had these specifications for the different levels of that variable, and that'll come up again when we look at this. Okay, so these things here, I'm going to say are things we don't even have to measure, right? The patient can come to the hospital and they can just tell us this information, right? So, I mean, we can ask, hey, how old you are? We can ask what type of chest, like describe your chest pain, then we can just write it down. So what I'm saying is there is no there's no action we need to take to collect, well, and we have to collect the data, but it's trivial to do, right? These are just things that happen pretty much automatically for anyone in the hospital. Your sex, age, height, weight, this sort of like really basic vital information gets noted on everyone's chart. So we can be pretty sure that we're going to have this information for a new patient because that's the kind of things we would collect. Okay. These here are things that I would say, you know, if someone's having chest pain, or having anything sort of related. If we're doing a serious medical workup of this person, we're probably going to get this information, right? So their blood pressure, that's not hard to measure. Their cholesterol, it's blood work, but you would get that in a normal physical. Your fasting blood sugar, same thing there. That would be in the same blood test as cholesterol. Sorry, those might be different tests, but one blood draw, you can generally get those things. And then resting EKG, that's a little beyond, but it's still a very non-invasive procedure. So we'd love it if we could say, use only these variables here, right? So that would mean based on regular old demographic information, chest pain type is not really demographic, but easily obtainable information, and then a simple blood test. Like if we could use just this information and then predict presence of heart disease, that would be great. Unlikely, but something to shoot for. Then we could say, okay, maybe we go one step further. Maybe we bring in information from an EKG because that's more information we need to gather. But if it really helps our predictive power, we'll want to bring that in. Okay, well, and then we can start thinking about these variables. It's like, well, we could do a stress test on the heart, but that's a lot more work, a lot more time. So these variables, we would maybe say, well, we don't really want to use them, but if they bring very good predictive power compared to not using them, we might want to consider it. This CA, we sort of think we don't want to use probably because this is related to the angiographic results here. And if we don't want to have to do the angiography, we don't want to have to input data about it. So we probably don't want to use this CA variable. And then this thal, we weren't too sure about this variable. It sort of seems to be about whether or not you already have a heart defect, unrelated to heart disease, say something like a hole in the heart, which is common in, I believe, sort of infants, or something like a leaky valve, like a valve that doesn't close all the way, like something that I deal with. So I think it's something like that. And we were sort of questioning whether or not to, kind of makes sense to use that, but because there's going to be so much missing information here because people just don't know if they have these things, we're probably not going to use this. Okay, so that was a little bit of recap about the data, but I just wanted to keep that in mind of while we have all of this data available to create a model, we don't necessarily want to use it because if we use it in the model, that means we have to collect it when we make a future prediction, and that could be a sort of impractical thing to do. So we definitely want to use these variables. We're super okay with using these variables. We will use these variables if we need to, but we'd really prefer not to. This one we're not going to use, and this one we're probably not going to use. Okay, cool. So my notes will change over time. Actually, let's make this a bulleted list in case we render this. Okay. And we might come back and add some notes here along time. So process. So what have we done so far? We've read data description. Okay. So we really need to start looking at the data more, but excuse me, we really got to test train split the data because it's no fair if we look at the data with the test data included, because then that test data is influencing decisions we're going to make about the modeling process, and we really shouldn't do that. So the very next thing we need to do is test, train, split the data. Okay, so that's what we're going to do next. So I'm going to start working on this R script here. So the first thing I want to do is read in the data. Okay, so and up here I'm going to load some packages. So I've personally been looking to use the data table package more and more, but I'm not super proficient with it yet. So I think I'm going to fall back to some of my tidyverse habits. So I'm just going to go ahead and load that because there's a bunch of things we're probably going to use from there. So in particular, let's say, well, I actually want to be lazy. So I want to use this import dataset feature to import the dataset. So if I do this, it sort of gives me the code to do it right here. This reader is from reader is from the tidyverse, so I don't actually need to load that. Notice that when you use this tool, I mean, it does nice things, like it tells us the data types, like double, double, double. There's character off the screen here that I'm covering up, but let's steal this code real quick. So I'm not actually going to import it that way, but I'm going to utilize that code. So I'm going to call hd equals like this. Okay, so this is the full data. So the next thing I want to do is test train split this data. Before even thinking about missing data or anything, I just want to pull off some data and say, I ain't looking at this until the very end. So that's my next step. Test train split the data. Okay, so far in this class, I think it's safe to say that we've been doing the test train split manually. And by manually, I mean I've been doing it for you, and the way I've been doing it is just simply sampling 80% of the rows of the data completely at random and going from there. We're going to look at a different way to do that. So I'm going to start introducing the caret package, which we've previously used for things like fitting k-nearest neighbors, but what we're going to find is that it's actually an entire system for doing some machine learning things in R. So it'll be useful to start thinking about this. So I want to use this create data partition function. So if we look at the arguments here, it asks for a vector of outcomes. So we're going to do that. We're going to supply the response variable here. And then the only other thing I'm going to supply is P, the percentage of the data that goes to training. So roughly 80%. And I'm going to run this and see what happens. Except I think it creates a list, and I don't want that. So I think there's this list argument, and I'm going to say false. Wait. No. I haven't done this in a while. Because I don't want to have to do it. No, I want list as false. Well, we'll see. So what this should be, these are the indexes of the original data that are going to go into training. So for example, 887 is going to be left out. So I'm just a little confused by the setup here. We'll just call this train IDX and sort of see what happens. So what I would like to be able to do is something like this, but I'm actually not sure if it works, but we'll find out. So does this create... No, it doesn't. So wait. I think they changed this on me, and it doesn't work the way... Well, hold on a second. Okay. Oh, there's... Okay. Oh, does it do I... Hold on. What does this return? So I want it to be a vector, but if I do list is false, it does like a data frame, which is no good either. Did they change this function on me? Return train when returns a value, return another. Okay, that's right. Logical. Should the results be in a list or a matrix with the number of rows equal to times columns? Oh, you know what? Huh. Okay, well, there's probably a cleaner way to do that. I think they changed this the way it used to work. I think this used to simplify to a vector if you did it like that. Well, here, let's do this. Let's wrap this in unlist. Okay. That would work too. And we're going to leave it like this for now. So we only did one resample, and this sort of shows that. Okay, so that aside, I think it would be safe to say that this would then be a training. Oh, whoa, hold on. So we should set a seed so that this is reproducible later. Then I run this to get the indexes that go into the training. And unfortunately, it's returning a list, so I need to select the vector that it returns. And then this would be the training data. This would be the test data. And now, okay, so that was a bunch of me fumbling doing this, but I want to say that, okay, so what's different between what I'm doing here and what I've done every other time that I have done test train splitting? And the thing we got to think about is why do I need to supply this? Like, normally you wouldn't care about that. So the reason for doing that, does it talk about it here? Point of group space and percentile. Okay, so this is the key sentence here, which is that we're giving it a categorical response. Actually, I wonder if that's true because it's not a factor yet, but let's assume that it is. It's basically taking samples that are stratified by the classes of this variable, so that way we have representation of this variable in both the training, of each level in both the training and test, and does some other nice things distributionally. So it's just a better sampling procedure than simple random sampling. You'll want to read here for details of that. Okay, cool. So I should probably call this HD underscore train, and I should call this HD underscore test. Okay. Okay, so now we have, I move myself for a little bit. We have our training data and our test data. So now we can sort of be a little safer and say, well, we're going to do whatever we want with the training data, and then we'll leave the test data out until the very end. Okay, so let's steal some code from myself here from this check data script that I provided. So this function is going to come in handy. And then, so what I want to do is apply this. We're sort of retreading some territory here, but I want to apply this function to the training data. Oops. Okay, so what we find is that within the training data, there is missing data. And we sort of said last time that what we were going to do is we checked how much missing data was in each variable, and we said we're going to get rid of these three variables because they have a high proportion of missing data. So I think what I did was this. So what was the comment I had? We'll maybe do more than 30%, or else that one variable won't get removed. So we'll do 30 here. But I need to do this within the training data set. Okay, so I'm willing to override that. Okay, cool. So later on, we're going to need to, well, I should say now create training data set without comments anymore. Okay. So eventually, we're going to need to apply the same logic to the test data. Ultimately, it kind of won't matter because all our models are going to be based on only. Here, let's run this real quick. only the variables that are within this data set. So if we provide data, actually, I'm not going to do this, but so if we use the test data as is, it would always ignore those variables, even though they're in this test data set. So we have no reason to remove them now, but we will have to perhaps do some other removals based on other things we do. So looking at this training data now, so now we're down to 587 training observations. Not the worst, not the best. We had more to begin with. I think it was like 700 and something before, but you know, it's a reduction that we're willing to live with though. Okay, so a variable that we have been wanting to look at is the response variable, which is this. Okay, so maybe two things we should do is coerce character variables to be factors. Okay, so this is one of those. And I think the other one that's an obvious character is the location variable. So let's do that real quick. Okay. Let's check that. Okay, so this is a factor. This is a factor. Some of these other variables should likely be factors, right? So sex here is a categorical variable, but it's already coded as a dummy, so we're going to leave it for now. Chest pain type, right? So if we go back to here. So chest pain type, there's 4 values. So right now it's coded as like 1s, 3s, 4s, and 2s, but those aren't numbers. Those represent these categories, which don't have any sort of numeric differences between them. So this variable absolutely needs to be a factor. I mean, you can try it as numbers, and you can evaluate how it works as numbers, so meaning like there's 1 between each possible level. But I'm going to go ahead and say that that needs to be a factor. I need to run that at some point. We should probably even go so far as to change like 1 to literally just say, oops, let's do this. Like a 1 for that variable should literally just say typical angina. But I'm gonna be lazy for now and not do that, but we should consider it. If we're thinking about other variables, okay, so this is clearly numeric. This is clearly numeric, which, you know, we can see here, right? So that's cool. Thinking about what I know about cholesterol, I'm guessing this is total cholesterol. I'd really like a split of this variable into HDL, LDL, which is something like with modern medicine, like that's what you get in your blood work. So like that's one improvement we can make to this data collection right away. Okay, so fasting blood sugar. This person doesn't have a fasting blood sugar of 1. This person doesn't have a fasting blood sugar of 0. It's that this person has a fasting blood sugar above 120 milliliters per deciliter, milligrams per deciliter, whereas this person does not. So that's also categorical. So let's do that. And actually, let's change sex while we're at it too. So what was I going to do? So sex is categorical in this case, and FBS is as well. And like with these 3, we could probably, you know, change 0s and 1s to be male and female. We could probably change these 1, 2, 3, 4s to be the actual type. And this FBS here, we could literally change to say bigger than 120, less than 120, but we'll call that. Well, you know, we'll add that to do. Change levels of factor variables for better understanding. Okay, so that's a note, but for what we're trying to do right now, it's fine. Were there any other variables of note that we need to change? Okay, so this looks to be, rest EKG. We need to go back to the data description there. what was I looking for? Rest EKG is number 19. Aha. Also categorical, right? There's 3 different categories there, so that's good. What was that? Rest EKG. Okay, so that needs to be made in a factor. And just sorry, this is a big part of what I say when I say look at the data. Like these are numbers, but they're not numbers. They're representing categories. Okay, Thalatch, what is that? Maximum heart rate achieved. Okay, this is clearly numeric. Xang, whether or not you got chest pain, that is a angina. Okay, so that's clearly categorical as well. So what is that? Xang. Okay. Okay, cool. So I kind of don't remember where I was in this code with respect to what I've ran and what I haven't ran. So I'm going to run everything from the top. Okay, cool. Let's have a look at our data. Okay. Factor, 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 and that all looks good to me. Okay, cool. So I think this is a really important step to do. What data do you have as numerical? What data do you have as categorical? I mean, ultimately, a lot of the methods that we have are going to change that under the hood for us because they just have to be numbers. But we should, as humans, go through and think about this. And you know, some models will operate on numbers very different than categories, depending on how they encode for categories and various things. So we want to be at least aware that we have a decision to make there. So I guess we're sort of... Oh, notes. So I would say that what are we doing now? We are doing... So we're kind of doing feature engineering, right? So anytime you take a variable and do something to it to make it a new variable, that's called feature engineering, right? And ultimately, feature engineering is an attempt to, you know, put better inputs into your model. And we're not maybe explicitly doing that right now. We're sort of just like engineering the features to make sense. But we could also tweak later on variables to perhaps try to get better results when we start getting down to that. Because it's actually possible that, like, while CP is categorical, even though it doesn't make sense, we could go back to coding them as numbers. And if we validate that it works better like that, well, then it works better like that. It doesn't make sense to us as humans, but the algorithms just worked better when you did that. So that's something to keep in mind. Okay, so that wasn't really what we wanted to be doing right now. We want to look at the data. But so feature engineering is a really broad thing where anytime you're sort of like messing with, well, how do I take this variable I have, manipulate it to be slightly different as an input to the model, that's feature engineering. We might talk about that in more detail along the way, but I just want to mention that that is one way to say what we were doing there. So, but I want to focus on this look at the data thing. Okay, so for one, we're looking at the data, right? One of the ways to look at the data is to say, what sort of data types do I have? Another way to look at the data is to say, well, what is the response? What are the possible features? Well, here's our response. Everything else is a possible feature. We've been doing that in a particular way, saying things like, well, you know, some of these variables we don't even want to use potentially. So that's also thinking about response versus possible features. We're thinking about size of data. So here are our number of observations, our number of variables. We can actually get a better view of the entire data by doing something like this. I think it's very useful to sort of just literally look at the data like this. Sometimes things pop out to you. One thing that's going to pop out to me at some point here when we find it. What is this -1? That's interesting. Shouldn't there be missing data in here? Or did I... Wait. Is there no missing data? No, there's got to be missing data, right? Something. Well, wait. We have a function that'll help us with that, right? So I need to redo this. Oh, sorry, we removed the missing data. I forgot we did that. So sorry. When we ran this code, not only did it take away the columns that we didn't like, it then took away rows with missing data as well. Okay. For now, I don't want to do that yet. Sorry. So now if we look at the data, one of the things that should stand out is there should be missing data. I don't see any. Ah, yeah, there is some. Okay, so there's a little bit of missing data. Okay, good. Okay, so we see some missing data. I think if we look, we need to assess at some point whether or not negative values are okay here. Ages range from like 28 to 77. Kind of surprising there's not some older folks than that in here, but okay. Okay, so that's a little bit about it. But so one of the first things I want to look at is something like this. Okay, so within the data set, remember that there are the training data without with the missing data still existing like by row, but there's no columns with a ton of missing data. There are 738 observations, 329 of them which show no sign of heart disease, right? So in some sense, this data is pretty balanced, right? Because one of the ways we might eventually look at this data is we might collapse these four categories into one and say we have people with heart disease and people without heart disease, and that's what we're going to try to sort of figure out and filter out, right? So that's something we'll want to keep in mind there. Sort of another thing we're going to want to keep in mind is that if I run this again, there is some missing data here. So not a ton. I think the most missing data we have is in this FBS variable, which is at 10% of it. And I think that might be fairly correlated with these other ones. If in this video I end up fitting a model, which I don't think I'm going to, given how much I've already rambled, what was I going to say? I'll probably start by just omitting all the data, right? But I think it would be nice if we didn't have to lose another 10% of the data, if there was some way we could keep it around. So we're going to think about that still, but we would have to do a lot more discussion of that. That might have to be its own video. But let's just look real quick at something. If I sort this, do all the NAs go to one side? Yeah. So, and something we might notice too, wait, oh no, why did that reset? So with this FBS variable, notice that sometimes it corresponds to another NA, but a lot of times it doesn't. So if we just remove any rows with NA, I think we're going to end up removing even more than 10% of it, which is, significant data loss. So if there's some way that we can, infer this from these other variables, that would be pretty good. Actually, if we look at let's look at that FBS variable real fast. In particular, okay, so these, wait, where's my cursor? Oh my gosh. Okay. These folks have a high fasting blood glucose or sugar, whatever you want to call it. These people do not. So one way we could deal with this, I wasn't going to go on this tangent, but we could say, well, this is the majority class, otherwise known as the mode. So we could just fill that in everywhere here as our best guess. Or we could try to do things like we could have like a mini learning problem within our larger learning problem is, well, first we want to infer these values from other values and then move forward. That can be a little bit tricky if we don't have like a nice pipeline for doing that. So we're going to push that off to the side, but that's something we definitely want to think about. Okay. So, sorry, I need to check my notes. Okay, so we did this. We did this. We're doing this. We're doing this. I'm gonna put like down here, fit a model, just to prove that we can do it, right? But I'm wondering if there's a okay. So in terms of looking at the data, right? What do we want to be doing, right? So we want to say, how do all these variables relate to each other, right? And that's kind of a really tall order, right? Is understanding that, right? So there are a million different plots we can do here. There's all sorts of different stuff we can look for, right? But some of that is going to be sort of taken care of by our models. So I think that I want to be careful here. I think that sometimes when folks say look at the data, people will infer that to mean make a bunch of pretty pictures. And that's not wrong, but I do want to sort of really emphasize that we have already done a ton of looking at the data without ever making a graphic. We spent a ton of time reading the description. We spent a ton of time thinking about just proportions within the variables. We spent time thinking about what data type should these be. Should they be numeric or categorical? We've thought about what is the response. We've thought about what variable should we use in our model because what are we going to have at test time? We've thought about where is the missing data. So, there's a whole world of visualization, which is great, but I think sometimes people just jump there a little too quick and miss some of the real key fundamentals. Speaking of a nice way to look at your data, let's look at this skimmer package, and then I think it's the skim function, and then I think this will do what I want. Okay, cool. So I forget if I've shown this in this class or not. I think I did a long time back, but now that we're doing analysis, this is really interesting. I love this output right here. It even has some pretty pictures. Not really, but it's kind of clever how they do it. Okay, so what I did is I used the skim function from the skimr package, and then I called it on our data. And it gives me this beautiful summary, which includes basically everything that I already talked about in one nice screen, right? So it goes from like high level information to lower level information about our data. Okay, so this is the name of the data set. There are 738 rows, which in our case means there's 738 different heart patients. There are 12 columns, which means we'll have one response variable and 11 possible features, but we get to decide if we want to use those or not. And recall that was after removing some of them. 7 of these things are factors, including our response. 5 are numeric. None of them are group variables. I'm not actually entirely sure what that means in this context. Okay, so then it breaks down the factors versus the numerics because we have different tools for summarizing them, right? So here it tells us the variable, how many of them are missing. Probably more informative of those is completion rate. So we have no missing data on sex or chest pain type. We have no missing data in the response variable. That's actually really good. And we have no missing location information. But there's some missing data for fasting blood sugar, this EKG variable, and honestly forget what XANG is already. But hey, we have notes on that. What was XANG? Exercise-induced angina. Okay, cool. Okay, cool. None of these are ordered factors. That's a whole different thing. You can have order in a categorical variable or not. Some of them maybe should be, but I don't think we're going to use any methods that would take advantage of that. It tells us how many categories each of these variables has. So for example, our response variable has the 5 categories, so the 0 category and then the 1, 2, 3, and 4. We might change that. We might roll it into 2. More feature engineering. Well, that wouldn't be feature engineering. That'd be response engineering. But and then it tells us which is the... it shows us counts of some things, right? So, for example, I'm going to go ahead and guess that 1 must code for male. Is that true? 1 is male. Yeah, I think men have more heart problems than women's, or at least in within this sample, there are many more men presenting than women. That would be an interesting. We should look at that within the data. Like within men, do more people have heart disease, like proportionally than women? But men seem to be overrepresented in the data. Type 4 chest pain was the most common. What is that? Okay, so most of the people in this data set don't even have chest pain. I guess that's good. Most people don't have a blood glucose problem. I forget what these are, but anyway. And then like we said, it's kind of balanced. Like the majority of people don't, or the biggest category is people with V0, which is no presence of heart disease, but there's plenty of people in the data set with heart disease. And then the Cleveland data is the biggest. And then what we have here is for numeric variables, well, you have to look at them differently, right? So again, age, no missing data. Everything else, we only have like 90-some% complete. We see the means of these variables, their standard deviations, quartiles and things. So like minimum, maximum, median, that kind of stuff. And then this is cute, a little histogram, but with like ASCII characters. That's kind of cool. So these are decent shaped things, nothing crazy there. Okay, cool. So this would be saying looking at the data at a pretty high level summary, and then I would call this univariate, so per variable summary statistics, right? You could certainly make like bar graphs of these to look at proportions. I just make the tables that I was making earlier. We could make these histograms bigger, but this is honestly gives you a lot of the signal that you wanted to look at there. Okay. So the next step would be we kind of want to maybe look at the relationship between some of these variables, especially between individual variables and this one here. So we could do something like plot age against blood pressure, and then like separated by this numeric. Let's see if I can do that. So what did I say? So I want to look at. Okay, so I should say that I'm not great at visualization. I'm not like a ggplot2 wizard. I think in terms of base graphics. I think in terms of one variable. You'll see. I'm guessing there are people in this class that are better at visualization than me. I'm not exaggerating. Okay, and then data is this. Okay. Okay, so I look at this and I see I see an ugly graph. Hold on. Okay, so I see a slight positive correlation between age and resting blood pressure, which that's not surprising, but I would really like these dots to be different colors depending upon this variable. So I think the easy way to do this would be like this. So color equals, I think I have to repeat this because this is not too bright, but like this. Okay, cool. So I don't see, nothing is popping out to me here, right? So I should probably make a legend here, but I'm gonna be a little lazy. So black is gonna be the first category. Actually, wait a second. Hold on. There's what is on here? There's red, black, green, blue. Oh, and science. So all 5 categories are represented. That might be hard to see. I don't see much here. There's probably some subtle patterns, but I don't see them. Yeah, I don't see anything obvious here. Wonder if we use a slightly different set of variables. Let's look at Oh, so this is interesting, right? So this is a good graphic. Now, I don't see a huge pattern, right? But I do see one thing that's a big problem, which there's a bunch of cholesterol levels of 0. So let's have a look at that, right? So if I filter what? So quite a lot of them, right? So all of these observations here have a cholesterol of 0? Excuse me? That's just not possible, right? So what this is really, to me, it's like hidden missing data. So we need to make a note of this. We'll put our to-do, let's put a to-do list in our notes to ourselves. So actually, let's put this over there. So that's something we need to do still. Look for hidden missing values like a cholesterol of 0. Okay. Sorry, I'm just trying to keep track of. We'll call this look at the data. We'll call this starting exploratory analysis. Okay, which falls under looking at the data. But okay, so this is great, right? So this isn't going to inform our modeling decisions. I don't think, like, if we ignore this 0 data down here, I don't see any strong pattern up here. Like, there's maybe more red here than elsewhere, maybe more black here than elsewhere. So that suggests that maybe these two variables will help us sort of tease out these categories. But the big takeaway from this plot to me is like, oh, good. One little plot showed us something really obvious. To me, what that says is I should come here and I should do this analysis real quick. Okay, so age looks good. Sex looks good. CP looks good. Okay, so this is a reasonable minimum. That's a reasonable maximum. This is not cool. That's fine. Those are categories. That seems okay. That seems okay. Okay, so like, are negative values okay in old peak? Let's make a note there. Look into negative values of old peak. Okay. Then that looks good. I created this variable, so I hope it looks good. Okay, cool. So, so yeah, those are the kind of things. So like, you'd love it if this somehow informed your modeling decision, but I think these are the kind of things you're going to find doing exploratory analysis. Like, this is like potential issues with the data, which are going to inform what you do later, but not necessarily be like, oh, look, these two variables are super correlated. I should use that in my model. Because like, if you put them both in the model would have figured that out anyway, so that's not as important. Okay, so I'm at the 53-minute mark. So just to say that I did it, I might just check something real quick. This isn't this. I don't want to modify this. I want to modify this. Can we fit a model? Okay, so let's do this. Caret. Wait, I have caret load already. Right? KNN3. What's the response? Num tilde data equals HD. I hate autocomplete sometimes. Okay, so I don't want to look at this model. I don't want to make predictions. I just fit it to the whole training data set without thinking. I just wanted to do this to say that, like, hey, look, the way we have the data formatted, it can go into our model fitting functions. Maybe let's look at this real quick. Okay, that works too. Great. I can fit a decision tree. That's not to say like I'm actually evaluating this as a model. That's just sort of a verification that all of the data wrangling that I've done has kept the data in a format that works the way we want it to. Okay. So I think that's a good stopping point, actually. The answer is yes. There's questions about what happened here. Like, for example, what did it do with the missing data? That's an important question we're going to have to answer. But for now, we have, well, let's recap what we did. We really focused on the data again, that's for sure. We did test train and split the data. We did that in a new way, which was using this check data partition, create data partition function, although you don't have to do that, but notice that it looks really similar to what we've done before. I fumbled with this a little bit. I need to go offline, look at the best way to do this, because this is not how I remember doing it, but it worked. It worked. We looked at the data in all sorts of ways. We questioned the types of the data. We questioned what variables we're going to use in the data. We found some interesting. We modified some of it. Right. We changed things to factors. We removed some data. We found some hidden missing data and that kind of stuff. And we proved that we can fit a model, but we haven't actually done anything with it yet. So, so these are things that we can do. But so our big looming to-dos are deal with missing data. We haven't done that. And then fit and evaluate models. Okay. So probably, so these kind of have to be dealt with simultaneously. So that'll be for upcoming videos. But I think that's good for this video. Basically, I feel good. We're in a spot now where I feel comfortable with the data. Now we really need to start the model building process, and that'll include dealing with the missing data along the way, because that's going to be a big part of the process, given that we have to deal with it here, and we'd like to keep as much data as possible. Okay. Gosh, I hope these videos are helpful, because it really just feels like I'm rambling, but I think that's part of the process. And even showing you simple things like the fact that I have to take notes as I do this, I have to do scratch work as I do this. Hopefully that enlightens you to the process, not just the fact that like, oh, hey, we see data, we fit model kind of thing. But yeah, okay. So as always, if you made it to the end of the video, good job. And I hope that I will see you in the next one.